All right, now we're going to talk about the law of cosines. So law of cosines also allows us to solve any triangle, but once again, just like law of sines, there were specific situations that we could use for law of sines. Law of sines, we could use the angle side angle, and side angle. Now for law of cosines, we can use side angle side, and that's about it. And these are our formulas depending on what information that you're given. So if you're a person that likes to have these formulas in front of you, I'd pause the video at this point in time and take a moment and write down these three formulas. If you're one of my students, these probably should go on a note card, as well as the law of sines from the last videos. Now let's move on and actually talk about these. So how would we go about solving something like this? Now, if need be, we can draw out our triangle and label the pieces of it so that we can do a little bit of work. And I have no idea what the layout of this triangle is, so we're just going to go with this and hope for the best. All right, so beta, ooh, and we've got degrees and minutes. Those are always fun. So beta is 34 degrees. So let's call this angle our beta. I'm going to change this. So 34 degrees and 20 minutes. We're going to put that right in here. So if that's beta, let's put our side A over here to be 13.9 meters. And this one will make this 10.0 meters. And then let's label on the things that we don't know. So if this is angle beta, that makes this side B. If this is side C, this is our angle gamma. And if this is side A, that makes this our angle alpha. And you can see that we have the side angle side situation. So if we've got B and this is our beta, out of these formulas, we're going to want to use one where we can have cosine beta. So this will be our formula that we're going to set up. So let's go through and set this up. So we've got B squared equals, because we don't know B, B squared equals, I'm just going to write the general formula here to start with. And then we're going to plug in our numbers. All right, once again, I don't know B squared, but I do know A squared is 13.9 squared plus 10.0 squared minus 2 times 13.9 times, I'm just going to write this as 10, and then cosine of 34 degrees, 20 minutes. And we're actually going to go through and solve this out. And by solving, I mean type all this in the calculator. Once again, we are in degrees. Even if it's degrees minutes, we are still in degrees. And so make sure your calculator mode is in degrees. Otherwise, you will get wrong answers again. And you can type in 34 degrees and 20 minutes, or you can convert it to decimal degrees. That is up to whatever you feel comfortable doing. But going through and doing this, I got B squared to equal 63.65. So then to get rid of the square, we square root it. And so we get B to equal 7.98 meters. All right, now if we know that B is 7.98 meters, I can actually look at this as angle side, side. It's up to you. Now, what I will say is I'm going to go through and I could do law of sines now to actually finish solving this triangle out. And I would do that, and I'm going to do it with the smallest side, because then I know that my angle will have to be acute. because I cannot have the smallest side with an acute angle. And by smallest side, I can't use B because I've already found beta, but I'm going to use this 10 and I'm going to find gamma doing that. If you want to use law of cosines again, you are welcome to do so. It's just a little bit more involved when you're finding the angle measure, which we'll talk about. I think maybe I should double check that first. Ooh, actually we don't. So let's actually talk about how we would use law of cosines again. So I'm going to use law of cosines. If I'm going to use law of cosines, a lot of times I use it for the biggest side because then I don't have to worry about two triangles with law of cosines. Just the way that the law of cosines works, you're either guaranteed one triangle or no triangle. So let's talk about how we would go about doing that. All right, let's see if I can get this all to move. Oh, that does not all want to move with it. Okay, we'll just move all this down. All right, so let's use law of cosines with angle alpha. That means that our formula that we're going to use is going to be a squared equals b squared plus c squared minus 2bc cosine alpha. And like I said, you could use law of sines to solve these, but I want to show you how to solve for an angle measure using law of cosines because you will end up having to do that at some point in time. All right, so our a is 13.9, so I'm going to have 13.9 squared equals b squared. Well, b we just found to be 7.98, so I'm going to use that, plus c squared, which is 10 squared, minus 2 times b times c times cosine of alpha. All right, now we actually have to do some actual work. So 13.9 squared is 193.21. And then I'm going to combine these two things right here. So I'm going to do my 7.98 squared plus my 10 squared. And I still have that 7.998 exact in my calculator, so I just left that exact in my calculator. And when I add these together, I get 163.65 minus, now I'm going to multiply these things. So I'm going to have 2 times, I'm going to use that exact value there, times 10. So I'm going to have minus 159.56 cosine alpha. I cannot combine these two things because this one is being multiplied times cosine alpha. So instead of thinking this is cosine, think of this as like a giant variable x. So if I had 193.21 equals 163.65 minus 159.56x, how would I solve it? Well, the first thing I would do is I would subtract this 163.65. So I'm going to do 193.21 minus, and I still have that value exact in my calculator. I can go back up and grab that. So I will have 29.56 here. This is going to equal a negative 159.56 cosine alpha. So now I'm going to divide by that negative 159.56. When I do that, I get a negative 0.19 approximately for my cosine alpha. So now I can use cosine inverse to actually go through and solve that. And I get alpha here to be 100.7 degrees. And then all I need to do is find gamma. Well, I know alpha, I know beta, I can find gamma by doing 180 minus those other two measures. And I'm going to leave them in decimal degrees. Typically, if it's in degrees, minutes, seconds, or in the DMS, you would keep it in that. But due to the distance learning that we're doing here, it really doesn't matter. This ends up being actually 45.0 degrees because it's 0.98. So if we round it. So our answers on this one, So let's get some answers written in here. So we're going to have B is going to equal 7.98 meters, Greek letters. So alpha is going to equal 100.7 degrees. I'm going to go ahead and grab my beta before I change things up here. Beta is going to equal 45.0 degrees. And now let's go up, I'm going to grab these degrees. So it's really important to make sure you put labels on things, but this right here is going to be my answer. Once again, like I said, if you're using law of cosines, you don't have to worry about two triangles. You will only ever get either no triangles or one triangle. All right, let's look at a word problem example. So a small plane is flying from Chicago to St. Louis, a distance of 258 miles. After flying at 130 miles per hour for 45 minutes, the pilot finds that she is 12 degrees off course. If she corrects the course and maintains speed and direction for the remainder of the flight, how much longer will the flight take? All right, this is another one of those fun questions that really makes you think about what your answer is before you get going. We're going to draw a triangle. I have no idea if that's what it looks like, but that's what we're going to label it as. And we're going to say, here is St. Louis. Here's Chicago. And it tells us that there's 258 miles in between them. And it also tells us after some time she's 12 degrees off course. So we're going to say, okay, if she's going from Chicago to St. Louis, that's where our 12 degrees is. And it says after flying for 130 miles an hour for 45 minutes. So we got to figure out how far that is. So 130 miles, and it says in an hour, so that would be 60 minutes. And that's going to equal how many miles in 45 minutes? So we need to solve that proportion, and then that distance is going to go here. So it's 135 hours. So I got a distance of 97.5 miles. 97.5 miles. And it wants to know how long it will take to finish flying this. Well, to figure out how long, we need to figure out this distance D. So here we go. We've got a side angle side. Well, that's perfect for finding using law of cosines. So if I'm going to do that, I'm going to have D squared equals 258 squared plus 97.5 squared minus 2 times 258 times 97.5, and then cosine of 12 degrees. Well, I can go through and calculate this. All I need to do is type that into the calculator because I don't have to actually solve for anything. Take a moment here and type that into the calculator and see if you get the same thing I do. I hope so, otherwise that means one of us typed things in wrong, and as we're not together, that makes it harder to compare. But I got this to be 26859.64, which means when I square root it, I got a distance of 163.89 miles. All right. Well, unfortunately, that's not our final answer because it doesn't ask how far she has to go. It says how much longer will the flight take. So using the same proportion that we had up here, we're going to actually determine how long that will take. So we're going to set up another proportion. So 130 miles in 60 minutes. This time I know how many miles I'm going. I'm going 163.89 miles. And we're going to say this is going to be m minutes. So what we got to figure out is how long that is. So once again, we have a nice little proportion to solve. You just cross multiply, divide, and it makes it much easier to go through and solve that. So 60 times the answer we just got. And once again, if it's in the calculator, you can actually use the exact form, which is really kind of nice. All right, so my total number of minutes I got would be 75.6 minutes left to fly. So that is my answer I got, is that 75.6 minutes. And that was using law of cosines, and I didn't even need to find all the other stuff. I just needed to find this one distance so I could figure out how long it was. So I don't even care what these other angles are. But that's an example of a word problem that would have you apply law of cosines, and an angle law of sines would be a very similar type of problem. So good luck with the homework.